Okay, so welcome everyone in our online webinar about platform engineering. And today it won't be about technology, because I think that platform engineering is in fact more a topic for managers than for engineers. And there are thousands of webinars on how to build the platform from a technical perspective, but not so many about why we should do it and how to approach platforms from organizational and strategic perspective. We will start today with DevOps concept to catch a common understanding what platform engineering actually is. And then we will talk about real numbers, how your company may be losing $2.5 million yearly, which is 50% of software delivery labor cost in IT, not even knowing about it. And we'll end up with successful platform pillars and how to introduce the platform which will actually save this 50% of cost and $2.5 million yearly for a large organization. Before we start, let me quickly introduce myself. My name is Krzysztof Hałasa, and I have a very complicated Polish name, so you can simply call me Chris. Past 12 years, I've played various roles in IT. I started as a software developer, then a manager, architect, ending up today as a head of DevOps in Xhorizon. Xhorizon is a small boutique technology and management consulting company which was established a year ago. The last 6 years, I've managed 4 internal developer platforms, mostly in banking sector, but I have also advised in automotive, retail, and technology companies who are building their own platform as well. I'm team topologies advocate and platform engineering ambassador, and I also lecture platform engineering in the university, and I blog about it in my website and on YouTube. Okay, so what is DevOps? I think we can all agree that there is no common, clear definition on it. I personally like the one crafted by AWS, which catches all the aspects: culture, technology, mentality, ownership. And for many years, my favorite was you design it, you build it, you run it, because it's a simple sentence. But what I've noticed is that sentence can be interpreted differently. And those many interpretations made a lot of companies a lot of harm. Okay, so you might think now how a single sentence can make a big mess. Let's start from the beginning. This is software delivery lifecycle process. It looks similar for years, and the difference between methodologies, waterfall, agile, etc., is mostly time for each phase and time box for all the process and who should do what. Of course, cloud containers, scaling, AI, those are things which are new, but even so, on the high level, the process looks the same for years. And one perspective of DevOps, a technology perspective, is focused on automating this process and supporting it with tools. So many years ago, a traditional approach for software delivery and operations was very simple. One system or few systems had been responsible for all domains or multiple domains. Deployments were not that frequent, and very often we have dev and ops tools like deployment, monitoring, code repository, configuration repository, etc., part of such a system. IT services was also simple. The responsibility laid mostly on runtime, and also development and operations were usually separate teams. So you design it, you build it, you run it, was either non-existing or had a very strict boundary on who is doing what. And this was plain and simple for IT managers because the business, but unfortunately, business expected more, more flexibility and more frequent releases. And in this model, system and people in the system ability to change was compared to turning around a huge cruise ship. You can eventually do it, but the time you've done it, everyone is already bored and half asleep, and competitors already won the market. So DevOps movement changed a few things. First, systems has to be designed for frequent releases, and this is leading to independence and specialization of the systems. More frequent releases and first end-to-end ownership for what is being delivered, because the IT team had also been more flexible and more responsive to the business needs. So systems became smaller, and we have more systems than we had before. Everyone who was implementing microservices knows about it. So we need to do something about those dev and ops tools because they no longer cannot be a part of the system. So what we did, we automated those tools and made them separate from the business applications. We made them more reusable. This is where Docker and Kubernetes ecosystem helped, abstracting a runtime, making it possible to be dedicated for each business application. And from technology perspective, landscape complexity became an issue. So a new profession appeared. We called them DevOps engineers. I personally hate that name, but we'll be using it because it's common. Who were expected to automate deployment and operations processes, so the application teams can deploy more frequently and have right toolset to own their systems. In reality, how we understood you design it, you build it, you run it, defined how we structured our teams in IT and where those DevOps engineers were placed in team structure. So there were DevOps teams which were centralizing dev and ops tools, and many times also taking part of ownership of the business application deployments. There were application teams who had own dev and sec tools and hire own DevOps engineers. And there were still systems which have the DevOps tools inside them, and usually those systems had been still owned by the teams taking care of those systems. So in general, where DevOps engineer works, where we put the tools and where we put responsibility for them, were very often a matter of chance circumstances, current architecture, timelines, and also particular team management need of control. Not always a real need, but still. Is it because you designed it to build it, you run it, had a mixed understanding even within single company? Where to put the boundary in this sentence for a single application team? You probably all agree that each team should not start building an application with real estate construction for a server building, right? Most of us will probably agree that you design it to build it, you run it means that team should be responsible end-to-end for business application value and logic. But what about deployment and observability tooling? And what about deployment itself? Is it part of the application? Or maybe a runtime as well? Maybe security tools, maybe network rules as well. Is it part of the application or not? Where to put this boundary is very often understood differently, even between managers and architects in the same company or even in the same team. So you may think now, okay, so what? Maybe we should leave it as it is. Maybe it's not a problem. So let me show you real numbers coming from one of the banks, which I calculated those numbers a few years ago before we started DevOps transformation. Let's talk about the biggest cost in software delivery and operations process, which is human labor. Sometimes licenses, but human labor is a huge cost. And we will start our calculation with that. And based on Bulldog Job report on Polish market, which I operate on, the average developer here makes like $40 an hour. So senior developers can do more, junior less. Professions like front-end, back-end developers, etc., may differ, but I think that this is a reasonable blended rate. So such a developer comes to a company, and after getting the laptop from IT, which is usually straightforward, this is where the ticketosis happens. The developer needs to find right people to provide access to repository, to database, to environment, to deployment, to monitoring, and so on. Often, multiple teams are involved here with multiple SLAs, and those teams have to be found, or the developer needs to somehow guess which Jira ticket fill with what kind of information. For example, I was onboarded a few months ago to one organization, and it took me a while to figure out which cost center I am allocated to. And those cost centers were not named. They had just letter abbreviations. So for me, it had no meaning as a newcomer. So let's assume that such a thing takes 1 week from getting a laptop to being technically able to release some code to production and see its result in observability. And the cost of this 1 week per developer is $1,200. And all of this because we have no simple onboarding process. If we have distributed teams and distributed DevOps engineers everywhere. Coming from technology-oriented team organization, we don't have like platform team, we have Kubernetes team, we have Grafana team, and so on. We have missing automations sometimes or poor requesting experience like I had with Jira. Okay, $1,000, not that bad, right? So similar scenarios when the new team is expected to build a new system or take over an existing system. This is also a scenario I encountered multiple times because I was working in a software house and I was often a member of the team or architect in the team hired by the customer to deliver some project or product. And the situation is also the same if you're building such a team internally. So what the new coming team needs first when they start? They need environment, they need deployment pipelines, they need monitoring tools, they need sometimes security approval to do something. They need network access to their application to expose it to the internet, to connect their application through APIs with other applications and so on. And common situation I experienced here is that I had to contact multiple teams to get all of this. Teams which also had different processes to deliver it, expected some upfront information which I had to find someplace else, like network APIs of integrated systems which I had to provide to the infrastructure team, for example. If the team is formed with new hires, all the problems a single developer has, now the whole team has, plus we need to create a working environment of for our application on our own from gathered pieces of what we need. Obtain security approval, make some formal documents, sometimes add some missing tools as well, running own instances if something is missing, etc. And if all of this takes 1 month and we spend 60% of our team effort on it, and the rest we are spending on actual business application, on design, on analysis, on coding on some local machines, on testing on some local machines, the onboarding process wastes $17,000. And the reason why it happens is the same with a single developer, but here we do not only onboard people, but we also onboard a new solution, like tooling for the new solution. And fun fact is that I had a chance to work for a large bank where this took us half a year. And the percentage was smaller, of course. We spent like maybe 20% of the effort on this, but still, imagine a cost for half a year of 20% of this. And this cost has been directly re-invoiced to the bank. So it's for a software house, it was easy money, right? On waiting. Okay, finally, we have our team onboarded and we start making releases. We are ready with the first release and we spent a month on security approval, missing environment configuration. We have to create own CI/CD pipelines, quality gates. We need to fill formalities, some security tests, things like that. So in the meantime, there are network communication problems with integrated systems and missing environment for test. So first release can be painful and can take weeks. The next ones will be much easier, taking just a few days. So if we blend it all together, we can say that, let's say it's 1 week. And let's say that during this 1 week for the release, we assume that 50% of the team effort are spent of those mentioned things. So if we spend 50% effort, it's $3,600 per deployment. Mostly because of the dependencies, some misalignment on who is actually responsible for what during the release process, This leads to meetings, which are costly, and here team is burdened with some tools recognition as well, like they need to fill some test tracking or security verifications. They need to spend time to find right people to help, etc. So it sounds probably familiar for everyone who ever worked in software house, delivering software for a customer, or anyone who started new application in company internally or took over the existing one. Okay, we can say that bug fix is just a small release. So all the formalities and security testing are not that painful here. But if we have distributed systems, highly integrated, and we have multiple observability tools specific for each system, which still happens, or worse, no observability at all, which happens more, it also can be problematic. So let's have a developer fixing a bug, and this developer is either fighting with the debugging tool because they're missing so many or so many, or fighting with permissions or gray area issues like who is actually responsible for scaling or performance, infra team or us, and they are fighting and they have a meeting about it. So let us say that all that figuring out and all that fighting and all that meetings puts one additional day per developer to fix a bug, compared to well-organized monitoring and observability tooling and boundaries. So such a day is $250. It's the same reason the reasons are the same. We had troubles with releases, and now it's time for the worst scenario, because the previous ones, bug fix, onboarding, release, can be somehow traced, somehow tracked, and it's visible, more or less. But the last one is very often about the mid-management position and their importance in a company. And the last one is about workarounding not working organization. Okay. So the last one, this is the scenario of the shadow IT in IT. I've seen so many teams called DevOps teams, which primary focus was runtime infra and observability automation. Okay, so you may think now it's not bad, right? Because this is what DevOps teams should do. But such teams are usually bottlenecks in IT, and not because they are understaffed, but it's because they are focused on automation, not on business application team needs. A real life example, in one of the banks, we had so-called DevOps team. They were provisioning Kubernetes cluster, and that was it. Deployment pipelines had to be created by each team. There were missing QA tool, so we had to create our own, being an application team, because the application was delivered in a regulated domain. It was a payment project. And we were waiting for database so long that we have created our own database server talking to infrastructure team. And there were a couple observability tools, but not each tool was production ready for the scale and size of our application we wanted. And as a result, we had to maintain own pipelines, own QA tools, own database. And even if we receive or reuse some tool like observability, which was existing, it usually had a missing configuration or hardening, allowing us to use it in scale. And as we are running highly critical and regulated application, we had to be fully compliant with the standards, and we had to reuse what has been provided. So other teams were not that strict, and company were running multiple DevSecOps shadowing tools, which DevOps team didn't even knew about it. So if you have such an organization and you're proud that you're hiring that many DevOps engineers, you may actually have this problem. And let's assume that only 5% of the business application team are spent of DevSecOps tooling, setup, and maintenance for own purposes. If this is only 5%, we will end up with $18,000 yearly wasted on that per team. Okay, so you may argue now that, okay, but thanks to this, you were independent. You were running on tools, so you were independent in creating your own application. Well, we were independent because we had to, and we were independent not in the area we wanted to be. Our dream was to be independent on making business decisions and making releases and not independently fighting delivery and operations tooling or maintaining it, which we didn't really care about. Our application was a standard Java app, like just orchestrating payment APIs. So we actually didn't really need its own tools to be independent. Let's calculate those numbers. Let's say we hire 300 people in our business application delivery and operations department. If we have 10% squad rotation, each developer works on 10 bucks a year, and we have like 50 project and product teams, each year inviting 5 new internal or teams or vendor teams, and those teams spend 5% time on DevSecOps tooling while they're reporting they're working on the application. A yearly waste of misunderstanding "you design it, you build it, you run it" sentence, and not designing an operating model addressing development and operations cognitive load is almost $3 million. And this $2,800,000 in our scenario is 60% of overall human labor cost in IT. My experience, followed by discovery, which I performed for multiple organizations, indicates that it's usually between 15 and 20%. For smaller and for bigger companies, it's the same. And $3 million yearly or less, if you're running smaller company, but you can actually make a calculation out of it, is wasted. As you can see, a misalignment in the "you design it, to build it, to run it" is costly, especially if you're at scale, and the cost of the scale starts to be a problem. And the root cause of the problem is the boundary, is where we put the boundary, and it's very often by chance. It's misaligned what we expect from application teams, what they expect from IT, from IT, and what are the business expectations. And what is worse is that executives, management won't be seeing this directly in an Excel file. Why? Because application teams will be reporting 8 hours a day working on the application logic or working on the application bugs. But this won't be true. As we calculated, 50% of this 8 hours a day is actually not working on the application logic or bugs. The team is waiting for environment, searching a right log in few monitoring tools, configuring some pre-done clusters, workarounding missing permissions to solve an issue, seeking information on people, fulfilling tickets or fulfilling regulatory forms, convincing security teams that they are okay to go to the production, upgrading, maintaining DevSecOps tools, etc., etc., etc. What they report is not what they actually do, because they are not working on the
Please, we
business
lost
application.
pictures.
You don't see pictures, okay.
Yeah, the presentation is lost.
Sure.
Oh, yeah, we are back.
So what the teams are reporting is not what they really do, because they are working on the business application. They are fighting cognitive load, and we are here today to talk about platform engineering. Platform engineering is all about reducing this cognitive load to minimum. Okay, so let's talk about how to save this ton of money. What is platform engineering? There are two definitions I like. First one comes from Circle-CI, and the first one is talking about what. The second one from Gartner is more talking about how. So platform engineering is a discipline which targets a business application delivery and operation teams' cognitive load by providing simplifications and automation to common overheads. As many people think about DevOps as an automation, platform engineering simplifies and automates those overheads. It's not focused on tools. It's focused more about capabilities of the business application teams and their needs in software delivery process, not just technology automation. So here is my definition of platform engineering. If we look at software delivery lifecycle as yet another business process in your company, with developers and customers in this process, we've got developers as customers in this process, and they have their needs. And we think about building a system supporting this process with functionalities addressing those needs. And the system will be a well-designed, well-engineered product, a customer-oriented product. We will have a platform. So platform is finding platform is about finding the right boundary, and you design it, you build it, you run it, and focusing on what's inside this boundary, like fully. So if you are familiar with team topologies, we have stream-aligned teams focusing fully on business value stream, and platform team who has to remove cognitive load of stream-aligned team, which may be there. So platform engineering is direct application of that concept. Platform does not necessarily has to be something huge. You can apply platform team even in a small domain scale just to validate the idea. Sometimes platform can be just a simple missing script, or sometimes platform can be just a Confluence page. But the real magic and the real savings happen when your whole IT for IT starts to think like product people and treat developers like their customers. And the biggest game changer, which is really saving this 50% of human labor cost, and the biggest challenge at the same time, is to define right platform services. And a good platform engineer is not focused on technology automation, but is focused on flow unblocking with those services. Okay, so let's talk about how the service is different than a tool. So a service has a well-defined channel, has inputs which are fitting stream-aligned teams' maturity, so they know how to fill it, and it is expression of what and not with how. So inputs are expressed with what, not with how. Based on that, we have a comprehensive outcome, fulfilling the need end-to-end, which is really important. So streamlined team can immediately use that outcome without a cognitive burden. So the outcome has to be understandable and digestible for the streamlined team. You can compare it to buying a car. If you go to the saloon, you just specify the color, interior options, and engine power. You don't need to specify how the engine should work, how the airbag should be opened, if the gear element has to be made of steel or made of titanium, etc. Or you don't need to run across the town and buy seats in one shop, a driving wheel in another shop, engine in another shop, and then put it all together. IKEA does not sell cars because assembling it would be hard. Assembling it would be a cognitive load for most of the people. So this is one of the perfect examples in real life scenario, which was actually implemented in one of the banks I worked with, which saved us tons of money every month. We knew that during the transformation, there will be a lot of new business applications coming to our company. So what we did, we created a dedicated onboarding service, focused on what is a usual cognitive load in such new coming team. And usually it's waiting, it's a need to configure something, or learn a new technology, or make a PhD out of this technology in order to use it. So how it worked? The new coming ticket, the new coming team had a Jira ticket where we had been asking such a team the things they knew off the bat, like application name, team squad, developers names, the language they want to write the application in, preferable branching strategy, which database technology they prefer, if the application has plans to be integrated with any other applications or exposed to open internet. We're asking the names of the applications which this application has to be integrated with, and some business details necessary to determine size and locations of the end users. So all the things which the application development team already know, like coming to the company. And here is the magic. In 15 minutes, what the business app team received was a complete delivery and operational environment, meaning all of the team members have access to a repository of the new application. In this repository, they find a demo service written in the language they wanted to use. This demo service has a ready-to-use CI/CD pipelines, which are deploying this application to their environment in Kubernetes up to the production environment. This demo service is integrated with logging, monitoring, tracing tooling, on which each team member can log in to those tools and define their own dashboards, alerts, and filters. This demo service is using the database the team wanted to use, and this demo service is approved by security to be released. This demo service has all the network configuration, which allows it to connect to the APIs of the systems which their application is going to be integrated with. And finally, team members receive a clear instruction and a person to explain all of these tools from the user perspective, how to use all of this. So from platform technology perspective, all of this had been done by orchestration scripts listening on the new Jira ticket. And as a result, instead of wasting $17,000 every time we onboard a new team, the onboarding was $45. Why $45? Because this is a cost of 50 minutes waiting for 6 developers in a team. So it's not even a pizza to feed them all. Here is a little bit of a bad news, because what is service for one company will not be a service for the other company. So you won't find one size fits all list of platform services to be applied. They need to be designed specifically for your organization. Why? Service has to be compatible on what the cognitive load of the teams is. Cognitive load happens usually close to this boundary between stream-aligned team and other teams. In our case, between an application team and IT for IT teams. There will be teams for which writing and maintaining on CI/CD is not only a piece of cake, but actually a real need, because CI/CD is closely coupled with technology they run or business logic they produce. A good example is data team or business critical large-scale application team. In this case, the boundary can be lower than just the standard internal application team, where there is no need for those teams to handle their own pipelines, for example. And the larger the scale of the company, the more boundaries you need to detect and address with the services. This has to be done methodically in a continuous manner. So how to build a platform? You probably already realized that the whole topic is more about work and organization than technology change. Organizing platform operating model and services is more a job for management. My experience tells me that 80% of the complexity happens here, but not many DevOps tools companies or platform providers mention this very often because it directly hits their business model when they have one standard operating model which they try to enforce you with. There are 3 pillars of every successful platform delivery, and only one is related to technology. First, you need to recognize the cognitive load. Then for that cognitive load, you have to define platform role and platform services, and only then do anything with the technology. One of the biggest mistakes companies do is starting with the point 3. It's like deploying a new business system in the company without any business analysis up front. So first, you need to recognize where to put the boundary and where this boundary is today, defined or not defined, on both technology perspective and organizational perspective. You have to map as is, and you have to plan the to be for organizational perspective and technology perspective. Then you need to plan services, which fits the boundary and cognitive load of the stream-aligned teams. There can be services to be used on enterprise level. There can be services dedicated for a selected team or even one team. All this has to be named. All this has to have own SLAs, success measures, and all this has to be proved. All of those success measures has to prove that this service is helpful or not. And once you have services, which are your platform functionalities, just like any other business application, you need to plan platform architecture. Starting from the bottom, if you are working in an enterprise, the tools are probably already there. Usually there are way too many tools compared to real needs, and tools are duplicating each other. So then, just like with front-end and back-end applications, you need back-end, where you define platform services like environment provisioning, and automate capabilities required to provide the service, like create namespace or create Git project. And on the top, you have a front-end where platform customer have an easy-to-use interface to use that service. It can be dedicated portal, it can be CLI, it can be even a Jira, as long as you automate it, and as long as it becomes a self-service. So platform is no different than any business application here. Since 2019, I've started my journey with platform engineering. Based on my experience as manager in a few platforms, I've created a platform delivery framework, which cover both organizational technology aspects of the platform delivery. The framework is available in Platform Engineering for Managers course I have released a year ago. In this course, I provide you with end-to-end guidance how to approach internal developer platform, starting with cognitive load analysis through platform service and architecture design, ending up with success measures, case studies, selling points you can use to convince your organization that the platform should be built, and some hiring tips for platform engineers and managers. For a price of Nike Air Max, you have my 5 years experience because it was released a year ago. Gathered in techniques, narratives, analysis templates, hints, which will save you sleepless nights and all the mistakes I've made managing platforms. The mistakes are also there. And if you don't want to make this journey alone, in Exorizon, we have a dedicated platform strategy service, which covers strategy analysis, KPIs, operating model, architecture, and release plan for the platform based on your current technology stack and team's maturity level, which we detect. We can help you build and operate your platform, bringing international expertise and years of experience in platform engineering and IT strategy. Okay, so let's conclude. At the end, I will share 3 common mistakes company does with platforms. First is they start with tooling deployment, not recognizing the needs. Infra team usually does not know what the developers' headaches are, trust me. So talk to platform customers, which is developers and ops guys, before you make a move. I also encourage you, like how to talk to those guys you can find in my course. I also encourage you not to make developers, not to make more headache for developers. And if you need to migrate applications to the platform, it's necessary that it should be done by the dedicated enabling team or platform team. Here, Exorizon can help you with the journey. And most important, remember that platform is not just some internal IT project or technology introduction. Usually the decision starts with platform strategy and IT operating model reorganization. And here is also a topic which Exorizon can help you with and specializes with, and did it many times. Okay, thank you for being on the webinar. And if you have questions, now is the time.
Okay, maybe I will stop recording so people can be more friendly for that.
Sure.
Oh, Chris, you need to stop recording.
I need to stop recording. Sure.
All right, just take a presenter. I will do this.